So today we'll be continuing with our functions and relations topic, and today we'll be continuing with the square root relations for functions and relations. So if we have a relation y squared is equal to our f of x, so essentially our function is some other function that's been squared, and we want to find a function for our y, what we do is we square root it and we get a positive and negative component. So the y squared equals to f of x component won't actually be a function because we'll have two variables for a given, two y variables for a given x variable, which will mean that it won't be a one-to-many function, so it won't pass the vertical line test. But we can draw these and look at them by graphing two separate things that are functions, and that would be positive, the root of f of x, and negative, the root of f of x. Alright, so let's have a look at how we do that. So in this example, for the function, we want to sketch the graph of y squared is equal to f of x, where our f of x is x minus 2. So let's have a little think about that. So, if we have our function, then let's look at what this means. So we have y squared is equal to x minus 2. So here I've just subbed in my f of x is y squared. And if we rearrange this, then we get x is equal to y squared plus 2. So this is actually a parabola that's not along the y-axis, it's actually going to be along the x-axis. So from here, we can draw this function, and it's going to turn out to be this. So it's just going to turn out to be an ordinary parabola where our vertices at 2, except it's now pointing in the x direction, not up or down in the y direction. And so note that if we go along here, this isn't going to pass the vertical line test even a little bit. It'll only pass it at this point here, but everywhere else it's going to fail. So how can we actually get functions from this? Because that's what we really care about this topic. It's functions and relations, but we mostly just care about functions because there's a lot of really good things we can do with them. So what we have to do here is we have to rearrange this expression. And we do this by saying that y is equal to the square root of x minus 2, and it's going to be plus or minus. So what this does is this splits up our non-function expression for x into two functions. And so if we graph these two functions, what we find is that when we have positive root of x minus 2, we get an expression that looks like this. So this is y is equal to root x minus 2. And if you want to have a look at this, then you can sub values in, but this is the expression for a square root function, and it is very much the same as what we would expect when we do semicircles as opposed to circles. When we square root it, we get half the shape, and the positive half is going to be in the positive y-axis, whereas the negative half will be in the negative in the y-axis. So this is y is equal to negative root x minus 2. So we end up with these two things that are functions, and if we put them together, then they represent this whole, which isn't a function of itself. So this is essentially how we use square root relations. If we can rearrange it and look at what the shape looks like as a whole, then it becomes pretty clear what happens when we have the positive and negative components of the root functions. And so this is what happens when we represent y squared equals to f of x. So we can represent it in these two components, which are, in fact, functions. Anyway, I hope that this lesson was helpful in understanding what square root relations are and how we use them. And I will see you guys in the next lesson.